Welcome to the AI and GIS Frontier podcast. Let's get into today's topic.
Today we are covering precision agriculture and AI. This is one of the areas where geospatial AI is delivering the clearest return on investment, with measurable cost savings and yield improvements that farmers and land managers can see on their bottom line.
What kind of ROI are we talking about?
The numbers are concrete. Combining UAV and satellite data with machine learning has reduced irrigation costs by 20 to 25% and decreased nitrogen fertilizer application by up to 31 kilograms per hectare without any loss in productivity. AI-driven disease detection achieves 81 to 95% accuracy and can identify infections 2 to 3 weeks before symptoms are visible to the human eye. For a large-scale farm operation, that early detection window can save an entire crop. For a forestry nursery producing millions of seedlings, catching disease early means the difference between losing a few trays and losing an entire greenhouse.
How does the satellite data pipeline work for these applications?
New commercial constellations like Planet's SuperDoves and public missions like Sentinel-2C are delivering 1 to 5 meter imagery with daily revisit cycles. That means near real-time monitoring of crop health, forest cover change, and environmental conditions. The workflow is satellite captures imagery. It gets processed through a cloud-based AI model, and the results appear in the farmer's or forester's dashboard. UAV satellite data fusion improves crop yield prediction to an R-squared of 0.83, which is remarkably accurate. For forestry, the same fusion approach works for monitoring reforestation success rates, tracking seedling survival across large planting areas.
How does this connect to forestry specifically?
Silviculture is essentially agriculture with longer time horizons, so the same techniques transfer directly. Site preparation, monitoring, planting verification, early growth assessment, thinning prescription development, all of these benefit from AI-powered satellite analysis. A reforestation company planting 10,000 hectares per year can use satellite monitoring to verify planting density and species composition across every block, something that was physically impossible with ground crews alone. The AI flags blocks where survival rates appear low, and field crews are dispatched only where needed. It flips the model from blanket ground inspections to targeted, exception-based monitoring.
What about environmental applications of precision agriculture techniques?
The crossover to environmental monitoring is strong. The same vegetation index time series that track crop health can monitor riparian buffer vegetation along streams, detect invasive species encroachment in sensitive habitats, and track post-disturbance recovery in restored ecosystems. Water quality agencies are adapting precision agriculture's nutrient monitoring techniques to track fertilizer runoff into watersheds. You can trace excess nitrogen from a specific agricultural parcel downstream to a monitoring point using the satellite data and AI models. That kind of source attribution was previously only possible with expensive field sampling campaigns.
Digital twins are showing up in agriculture too?
Yes, agricultural digital twins combine satellite data, soil sensors, weather models, and AI to create virtual replicas of farm operations. You can simulate different management scenarios before implementing them. For forestry, the concept translates to stand-level growth simulation informed by real-time satellite data. Imagine a digital twin of a forest management unit that updates daily with satellite observations and can simulate the effects of different harvesting strategies on timber yield, wildlife habitat, and watershed function. Some progressive forest companies are already building these systems, integrating their growth and yield models with satellite monitoring and AI-based predictions.
What is the outlook for the next year?
Hyperspectral satellite missions are the next big leap. Current multispectral sensors capture a handful of spectral bands. Hyperspectral sensors capture hundreds, which means you can distinguish between tree species, detect specific nutrient deficiencies, and identify pest damage at a level of detail that was previously impossible from space. When you combine hyperspectral data with AI models trained on ground truth from precision agriculture, the accuracy improvements will be substantial. For GIS professionals working in agriculture or forestry, I would recommend starting to learn about hyperspectral data processing now, because it is about to become much more widely available, and the demand for analysts who can work with it will surge.
Great practical advice. The precision agriculture space is clearly one where AI and GIS are delivering real, measurable value today.
Absolutely. This is not theoretical. The ROI is proven, the tools are maturing, and the satellite data infrastructure is only getting better. It is one of the most actionable areas in all of geospatial AI.